So good afternoon, ladies and gentlemen. In my talk, I will show how big data and crowdsourcing can help us to better understand weather and climate in cities. Cities are very important areas nowadays, since over 50% of the world population lives in cities, and this is foreseen to increase to over 60% by 2030. People do not only live in cities, they also work in cities. They produce their goods and services in cities. And in the future, with smart cities, they maybe also harvest their energy in cities via solar panels and wind turbines. So we need very accurate and clear environmental quality to have viable cities. But there are several challenges ahead, mostly from the climate perspective. First of all, we expect that the number of extreme warm days and heat waves appear to increase, and it has severe health impacts on vulnerable groups. For example, the elderly, children, people with cardiovascular diseases, and also labor productivity might go down. The other challenge is the amount of precipitation. We foresee a strong increase in heavy precipitation events, and sometimes the intensity can be stronger than what the sewer system can handle. And that means that certain areas, including critical infrastructures like roads and railways, etc., might be flooded, and cities need to cope with that. The last item is the air quality. Several days a year, the air pollution concentrations in the Netherlands already exceed critical levels that we have formulated. And this is not only a Dutch problem. Also, if you remember, for example, the smog episode in China, in Beijing, in November 2015, at that time the air pollution concentrations were about 1,000 times higher over there than what we experience here as normal. So overall, to understand and to cope with these kind of aspects, we need to know the environmental quality and weather and climate in cities. But what do we know so far about weather and climate in cities? That is not so much, because traditionally the National Weather Service are only allowed to measure weather and climate in rural areas, in remote places far from cities. So there's a clear knowledge gap. So in a project together with the hydrology group of this university, we studied how smartphone users can be used to record air temperatures in cities. Nowadays, nearly everybody is carrying a smartphone in their pocket, like I do at the moment. And how can we employ this device for environmental monitoring? So what we assumed, or what we formulated, is a very simple model in which the heat of the smartphone is translated on one side to the air, on the other side to the human body, and by that we can formulate a model to retrieve air temperatures. Now, first of all, we did a study for 8 cities in the world, and I will only show the results here for London in the UK. The blue dots on the screen show you the amount of data that are available in the city, and they are exactly where we want to have them, namely in the core of the city and also the suburbs. That's where the National Weather Service do not measure their weather. And it's also a big data effort, because we have about 800 records a day. The question is then, does this also work? I show here a time series of a summer weather, and in the black line is the observed air temperature, and the yellow line is the observed battery temperature of the smartphone. And you can see that the dynamics of the two signals clearly coincide, especially for the hot summer days with the red arrows. So high air temperatures are indeed reflected into battery temperatures, so we can use them in the crowdsourcing. And the blue dots are our model forecasts, and you see they work reasonably well. So far, we only treated the monitoring. Getting observations from smartphone batteries is one thing, but the question is, can we also forecast it? Can we predict it in advance? And if you look to the weather forecast in the evening on television, the lady only shows you for 6 locations in the Netherlands what the temperature will be in remote places on weather stations. But that's for the applications that I mentioned before, not where we want to have them. Maybe we want to zoom in more detail, namely, we want to have a weather forecast for the Dam Square in Amsterdam. And what do you need then in that case? First of all, we need to know how the city looks like in terms of morphology. So we need to combine big data sets again, for example, from the National Building Database, the National Water Database, including water bodies temperatures, the Land Use Database, as well as the Elevation Database. Now, if you glue that together in a clever way, and I talk now about data that are available on a resolution of 5 centimeters sometimes, we can make a beautiful representation of the city of Amsterdam, and including all the information that is needed by a weather forecast model. So this nice map is put as under a weather forecast model, and then we see what we get. I will show a short clip about a weather forecast for a heat wave in 2015 in July. So what you see is the temperature forecast for the city of Amsterdam. Blue is cold, red is warm, and there are several things that are surprising. First of all, the temperature dynamics is very high, both in time and in space, maybe much more than you would realize from your own experience. The other thing that is important, or what's directly seen, is that water bodies pop up as warm areas during the night, but relatively cold areas during the day. And finally, also, there are differences in temperature in different neighborhoods. Some areas are warmer than others. And it's best seen here in this time slice for the 2nd of July at 3 o'clock at night. The core of the city of Amsterdam is hot. The canal system is even visible in the forecast. In the south, the remote areas, the countryside is relatively cool, but in the northwest you clearly see the harbor area to pop up as relatively warm. So with that I conclude, okay, with the big data effort that we have done here, by combining the data and the supercomputing, we can make a weather forecast at a garden scale or street scale. Now, having a weather forecast in several files available on a drive is one thing, but we have to also communicate it to a user. So in another project, we built an app that reads the data from the previous forecast that I just showed and translates it to a site-specific forecast about how people perceive the weather. For example, this morning it was outside, it was cold and very windy, and we have a negative experience and negative perception of the weather, and that means that we would be in the blue scale of the app. Now, on hot summer days, we would be on the top of the app with very high temperatures and adverse health effects due to heat. For example, the mortality in the Netherlands increases by 30 deaths per week per degree centigrade. With this app, people can make a forecast for their thermal perceptions and maybe also modify their behavior, postpone sporting, drink more, or move to another location. So how does the app work? There are 2 axes. On the left, you see the windy cases. On the right, you see the calm conditions. If you are in the sun, you read the scale on the sun. If you are in the shadow or in the cloudy conditions, you read the scale at the cloud. And we can look with this forecast 36 hours ahead. So we started in the early morning, then it became warmer for a while. Now we are back in the night with a negative perception, and so on. So a site-specific forecast is possible. This app was released last year, just before the heat wave in July 2015. And on the graph of the Netherlands, you see the number of requests to this app. About 300,000 app requests were performed by the citizens in the Netherlands. The data cover over the Netherlands as a whole is well distributed, but specifically for the urban areas like the big cities in the Netherlands, that's where we intended to make our forecast for. This app is highly used, so apparently it also fulfills in a certain demand. Now, I hope I convinced you that crowdsourcing is a very useful tool to help science forward. So I would like to invite you to join this research by installing both apps. On the left side for you, the weather perception app, where you can get your site-specific forecast, and on the right, the battery temperature data record app. And I will be happy to help you to install it in your smartphone during the drinks. So far, I only talked about temperature, which is a relatively easy meteorological variable, and there are more challenges ahead of us. So in the future, we can work on intense precipitation, including the runoff, also air quality issues, and finally, solar radiation and wind energy harvesting in urban areas. So I would say, let's make cities smarter in the future. And with that, I close my presentation.